Let's take a look at a lab problem from section 5.1. This problem is asking us to look at the speed of the runner that's increasing steadily during the first 3 seconds of the race. Her speed at half second intervals is given in the table. Find the lower and upper estimates for the distance traveled in 3 seconds. So here we have the t value in seconds, that's the time in seconds, 0, 1, 2, 3, and half second intervals. And then this is the speed that they marked. So they want us to use either L6 or R6. So L is the left-hand endpoint approximations and R is the right-hand endpoint approximations for lower and upper estimates. So we can see that the runner's speed is increasing steadily. Well, steadily. It's 0, 6, 10, 14, 18, etc. Then one of these expressions, the L6 or R6, will be the lower estimate, and then the other expression will give us the upper estimate. So I have the scatter plot plotted in Desmos, and we could take a look at this plot. We don't have to connect it, but I think maybe if we think about connecting it, we see that the graph kind of looks like this. I prepared a bunch of estimates, or rectangular estimates, to try to find the area under this curve using these sample points. And so if I take a look at the rectangles that we would create in these half-second intervals, this is actually using the right-hand endpoint. Using the left-hand endpoint would start off with 0, because this would be the left-hand endpoint. So it's not actually, you can't see it because it's going to have height of 0, and so the first rectangle would be in here. Oh, let's take a look at the left estimate. So the left estimate would actually be, let's add another one here. It would be 0, y equals 0, for values that are between 0 and 0.5. So that's the first rectangle that we would have. Now I wouldn't really even call it a rectangle because there's no area there. So let's take a look at this one, and let's match up the color so that it's looking at the same color. And let's say this is an area from 0.5 to 1. So this would be the left-hand rectangle for the second rectangle, the left-hand endpoint rectangle for the second rectangle. And then we'll take the third rectangle. Oops, bummer. There we go. Let's take the third rectangle, adjust the color, and let's call it from 1.5 to, from 1 to 1.5. And so if we continue on doing this, we'll see that, let me just do one more. Our next rectangle would be this at 10.8, and matching up the colors and going from 1.5 to 2. Whoops. 1.5 to 2. This is what we have. So it's not complete, but you get the picture. You see that compared to the graph itself, these rectangles are going to be below the graph. So the left-hand endpoints will give us a lower estimate. Now let's hide these for now. And let's take a look at what happens if we use the right-hand endpoints. So if we use the right-hand endpoints, you see that it goes a little bit over the graph, and so we have upper estimates. So our lower estimates would be L sub 6, and our upper estimate would be R sub 6. All right, now that we know those values, the subinterval here have a width of whatever the delta t is. So if we take a look at the difference between any two consecutive t values, you see that the difference is 0.5. So let's put 0.5 for the difference there, the delta t. All right. Now the first two subintervals between 0 to 0.5 and 0.5 to 1, when calculating the left-hand endpoint, the first value, so we're looking at the left-hand endpoints. So these are the left-hand endpoints. The first value that we get is 0, from 0 to 0.5. From 0.5 to 1, the value that we get is whatever this value is at 0.5, which is 6.2. So our first value is 0, our second value is 6.2. Right, so enter your smallest to largest values in the steps. And so here we just really need to look at the table. We're going to go to 6.2, 10.8, etc. And we end at 19.4. We didn't go that far in our graph, but if we were to go to 19.4 here, this would be our graph from 2.5 to 3. So this is the last graph that we would have. I think we're missing one. Yeah, we're missing one. Let's throw that last one in. The one that we're missing is going to be this. Squeeze that in here. Actually, we would squeeze it in here somewhere, and this would be the graph from 2 to 2.5. So here we go. This would be the complete set of the lower estimates that we would be adding. So how many rectangles are there? The first one is the 0 rectangle, so that's a 0 contribution. And then the next one has height of 6.2, and then 10.8, and then 14.9, 18.1, and this is the last one, has a height of 19.4. And so that's what that is. Looks like we'll need a calculator to to calculate this, and it looks like we're just going to be adding these numbers. So let's take our calculator out and add up these numbers. 0 plus 6.2 plus 10.8 plus 14.9 plus 18.1 plus 19.4, and then we have 69.4. But remember, there's a 0.5 in the front here, so it's going to be divided by 2 or multiplied by 0.5. So the whole total here would be 34.7. So that's the left-hand approximation, and it looks like it's going to be a lower bound. And so now they want to find the upper bound for us. So the upper bound, let's turn that one on, turn everything else off. So the upper bound will be these rectangles and all the way to the end, and the last rectangle is going to have a height of 20.2. Our first rectangle is going to have a height of 6.2, so we actually start off with 6.2. So 6.2, and then we just carry on with the rest of our points. 6.2, 10.8, 14.9, 18.1, 19.4, and then our last one is 20.2. And so we add that up. Now, in our calculator, we added up 0. Let's multiply this by 2 again. So when we added up all those numbers, we had 69.4. We added them up to 19.4. So let's just add one more, 20.2. And then we have 89.6, and that's the one we're going to multiply by 0.5, and so we get 44.8. And then we have found our upper bound. So we have a lower bound of 34.7 and an upper bound of 44.8. And if we were to take the average, we'll probably get a good approximation of how much distance this person covered. Okay, hope that helps.